will start with today's lessons, and the focus of this episode will be on triple bonded alcohols and double bonded alcohols, including aromatic alcohols. So let us begin today's class. Before I begin, I would like to solve the questions which I had given in the last task. My task 1 was, I had asked you to draw the structure of isoamyl alcohol. Another way of remembering isoamyl alcohol is you can call it an isopentyl alcohol, right? So if you know isopentyl alcohol, that amyl can be exchanged with pentyl, and this is how you can go about naming this compound. So it is isopentyl alcohol and its structure. Iso means a carbon containing a CH3, and an H. So pent means total of 5 carbons should be there. I have only 3. 1, 2, 3. Increase the carbon, 4 and 5, and attach an OH. So this is isoamyl alcohol or isopentyl alcohol. This is the common name. And if you want to note down the IUPAC name of this compound, the numbering would be from here, the priority functional group. So it would be called as 3-methyl butanol, butan 1. So this was the first task. The common name, I'd asked you to draw the structure, and the IUPAC name is 3-methyl butanol. The second task which I had given was to draw the structure of pentamethylene glycol. Pentamethylene means it should contain 5 CH2 groups attached back to back. So this is your pentamethylene, and the word glycol is commonly used for 2 OH groups. I have the terminals only, which should be occupied with the OH group. So this is the structure of pentamethylene glycol, and if you want to give another common name, you can call this carbon as the alpha carbon. The carbon attached to the functional group is the alpha carbon. So alpha, beta, gamma, delta, omega. This can also be called as omega glycol. And the IUPAC name, I don't have to explain to you. It's 1, 2, 3, 4, 5, pentane. I hope you still remember that you are not to drop the E if the functional group is repeated more than once. So it is pentane 1, 5, diol. So this was my second task. Going to my third task. The third task which I had given was a CH3. So I hope this was a little tricky. Let's go ahead with the lowest addition rule and see which way the numbering would be correct. 1, 2, 3, 4, 5. So I have the substituents, the OH at the 1 carbon, the 3rd carbon, and the 4th carbon. 8, and let me number it reverse. 1, 2, 3, 4, 5. Let's take this numbering, the green one, the OH groups are coming on the 2nd, the 3rd, and the 5th. So it is 10. So you know which is correct. The black numbering is correct. So we would have to name it. Always whenever there's a doubt, you know, you would just number it and get the correct answer. So this is correct. 8. So it is 1, 3, 4, pentane, triol. Or otherwise, you could have even called it pentane 1,3,4 triol. So this finishes my task. For today's discussion, I will take up double bonded alcohols and triple bonded alcohols. And after I'm done with that, we will go to aromatic alcohols. So let us start. This compound, this alcohol is not stable. Why? Because it undergoes a phenomena called tautomerism. So there is a phenomenon of tautomerism where, you know, it can, where an alcohol can exist in the enol form and the aldehyde or the ketone form, that we will not discuss in this video. We will take it up in my next forthcoming videos. So since this does not exist, I mean, it exists, but it's not very stable because it exists in the enol and the aldehyde or the keto form. So we will go to the next alcohol, which is stable. See, I do not have the double bonded carbon containing the OH. So if I do not have a double bonded carbon containing the OH, then this alcohol is stable. It exists in its original state. So going to the common name of this compound, since the sp3 carbon contains the OH group, so this is allyl in the common system. So this is allyl alcohol in the commons. Now at this point, we need to know which has more priority, is the OH group or the double bond. Okay, out of the OH and the double bond, if you see the priority series, the OH group gets more preference, more priority in the priority chart compared to the double bond. So the numbering in the IUPAC system will start from the alcohol and land up to the alkene. So the IUPAC name of this compound is prop 2N1-ol. One very important correction needs to be done. If the alkene has some other functionality to be written after it, the E is dropped. It's not propene, it's propanol. All right, so E is replaced. En is written with the ol. So this is the IUPAC name of this compound. Proceeding to the next compound. Let us focus on the double bonds for this time being. I do not have to teach you the IUPAC name of this species, but in case if you are looking for the IUPAC name of this compound, yes, it is but. Your first carbon cannot be the carbon attached to the OH. The first carbon cannot be. The longest chain rule is not to be forgotten. So you cannot miss out the carbon which I have numbered first. You cannot argue with me and say that, okay, the carbon attached to the OH is the first carbon. No, it should start, you should have the longest chain, all right, containing the OH. So this is the longest chain and the IUPAC name will be but 3N2-ol. Okay, and let me teach you the common name of this compound in the carbinol system, because there is no other common name that can be assigned to this compound excepting that in the carbinol system. So if you see, this is the carbinol. If you still remember what is carbinol, that is, if you have forgotten, no, you will not remember. So just a small reminder that the carbon containing one OH group is carbinol in the carbinol system of naming. So it is like the group which is left without the carbinol carbon is methyl. This is vinyl. And then it's called a carbinol. So this is the common name of the compound that you can assign to it. So let's proceed further. Let's do the same thing with triple bonds. And triple bonds also, you know, we would not take a carbon where the triple bond is attached. We will go to a third carbon where we have an OH. The OH groups get more priority compared to the double bond. Here also, the OH group gets more priority compared to the triple bond. So in the IUPAC system, this is prop 2 YN. You will drop out the E because we've got to write 1 all. So this is the IUPAC name of this compound. And yes, does it have a common name? I'm fascinated by common names, and it's like putting in a lot of effort and remembering them. Yes, we have mentioned this compound in my previous episodes, and I sincerely hope you remember it. But anyway, if you have forgotten, it's a small reminder that this is propargyl. PRO ARGYL. Yes, this is a propargyl alcohol. So with these few examples, and there is nothing new to be taught in this. You can go on adding functionalities and go on naming these. These are the basics. So moving on from double bonded and triple bonded alcohols to benzene related alcohols. So the first compound which I would like to discuss is this. I hope you still recollect from my previous episodes that this is the benzyl group, benzyl. So as we had benzyl chloride, similarly we have got benzyl alcohol if we put an OH on the CH2 carbon. So the common name of this compound is benzyl alcohol. We are interested in the common names also. So the OH group is attached to the CH2 group, not on the benzene ring. So because the CH2 group is attached, the OH group is attached to the methylene carbon, this becomes the parent. This becomes the parent. So the parent is containing one carbon. So yes, if you have guessed, it is methanol. That is perfect. And what is this group besides, besides calling it a benzene? No, it is never called a benzene when it is a substituent. You will call it, yes. Oh, you have said phenyl. Excellent. 100 marks for the answer. Full marks for the answer. So it is phenyl methanol. All right. And what about the carbinol system? We have a carbinol system also of naming it. Yes, correctly. Yes, that this is carbinol. So we'll call it phenyl carbinol in the carbinol system. Okay, so is this an aromatic alcohol? No, this is not an aromatic alcohol because the OH is attached to the side chain. If the OH is directly attached to the benzene, then it would be, we will call it an aromatic alcohol. This is not an aromatic alcohol because the OH is attached to the side chain and not to the benzene. So it is not an aromatic alcohol. So now I will start naming aromatic alcohols. Yes. So the aromatic alcohol will take up the monohydric aromatic alcohol is phenol in the common system. And what will be its IUPAC name? Yes, it is hydroxybenzene. OH is the hydroxy, just like you have your sodium hydroxide with an OH. So this is the hydroxy group. So this is hydroxybenzene. So we can do a lot of variations. So having spoken about double and triple bonds containing OH and a benzyl alcohol, we will carry on the discussion about the OH attached to benzene, which is an aromatic compound, in my next episode. So do not forget to share, like, and subscribe. Thank you for watching.